All right, just started the recording.
Now everybody goes silent.
Yeah.
Somebody go first. Well, my name is Roy Butler, and I'm the tech support manager for MidNite Solar, but you probably already knew that. And Raechel is here. Raechel is the keeper of the obscure stuff when it comes to the KID. I'll be referring to her from time to time. And Raechel, you want to introduce yourself?
Yep, I'm Raechel Cluley. I've been working with MidNite for about, well, 2 years now. And the KID has been out, basically when I started working for MidNite, the KID had just come out. So I've been with it since it started.
All right. And just a quick background for me so that I did a little bit more than just read this in a book. I've been doing electrical work and all for about 45 years, and been doing solar and wind for the last 20. And so hopefully I can give you some decent advice on installation tips and practices, etc. All right, well, first of all, to continue our discussion from earlier, you let me know what you've got for a daily usage and also for the type of panel that you're using, and all that sounds good. What are you using for batteries before we start this presentation? I just want to finish this line of thought.
Right now we have full river 260 amp hour batteries. They're AGM.
AGMs, yeah, okay, full river AGMs. Okay,
and we have 4 of those in our enclosure for the systems that we're putting together now.
Okay, so you're in a series parallel configuration then with 12-volt batteries?
Yep.
Okay. Yep, 4 12-volt, got it. Okay, sounds good. What's the amp hour rating of those AGMs?
260.
All right, so you've got a 520 at 24 then?
Yep.
Okay, 520 at 24. All right, that's good. All right, well, we're going to start on with this. We'll give you the glossy marketing presentation here first, and then we'll get down into the weeds and get down into technical discussions. And feel free to ask questions anywhere along the line here. I do better with questions. So we've got the 2 different KIDs, as you can see here. I'm assuming you're probably using the black KID model here, and because the other one is marine, or am I mistaken on that? Which ones are you getting?
We ordered in the marine, but we ordered them in black.
Okay. All right. Yep, good choice. All righty. So there's the culprit. This is the person that invented this KID. It's Mario, and if he shows up at some of the shows. Do you guys ever get to Intersolar or anything like that?
No.
Okay, it was in San Francisco. Yeah, it was in San Francisco last year. I think it's in San Francisco every year, but Mario was there last year. But anyway, that's Mario. I think he was the #1 employee at MidNite, wasn't he, Raechel? First one?
Yes, he was their very first employee. He started actually working for MidNite, just sweeping the floors, and from there Bob taught him, about a lot about electronics and stuff, and he has continued on to, he's currently in college. I'm not exactly certain what he is studying for, but it's something related to the industry.
Very nice.
Yep. Yeah, definitely grassroots there. So let's see, what else do we have here? Yeah, the one thing about the marine KID is it does come with all the extra parts and pieces. The black, if you just order the standard black version, the battery temperature sensor does not come with it, and you don't get the little pieces of conduit and that type of stuff. So that's a pretty good choice. You get all the installation materials there that help you put it all together. Now, you probably don't use the lighting controller, or do you have plans to use the lighting controller at all? Do you need, like a service light in these enclosures or anything?
No.
Okay. All right. So it's probably the lighting controller and automatic generator starter really not the big deal for you guys.
No, I don't. Nope.
Okay.
So do you wire directly into the load circuit, or are you wiring off the battery, or do you have an inverter in that part of the system?
We will be going from the batteries, we'll be going to to an Acopian DC to DC power supply,
Okay.
and then into our controller for the tagging system, for the antenna system.
So all your loads are DC?
Yes.
Okay. Any idea on the loss on this DC to DC power supply? The efficiency of it?
I don't know what the efficiency is.
I don't know what the loss is on the
You know, we're actually going from a 24 volt to a 28 volt.
Oh, I see.
Yeah.
All right, so you'd like to think that...
Which increases our load a little bit, but...
Right, you'd like to think that only going up 4 volts wouldn't be as bad as doubling it or something like that, maybe not as much of a loss. Okay. So Raechel, I'm going to let you jump in here on this one. As I recall, one of these lights does something a little bit different than what in this description. Doesn't one of these lights have a double usage?
Well, I think it's probably the blue clipper light on bottom, because I know that it says for clipper, initially when the KID came out, we thought that this KID would be able to be used for wind and hydro as well as solar. And as time has gone on, we've discovered that really it's in our best interest as well as that of the KID to actually create a clipper that is specific for the KID. So that blue clipper light, it signifies that a load has come on, but also if it starts to blink on you, if you have a low battery disconnect set up, so say you are running something off the KID load circuit and you've set up your low battery disconnect, and for some reason the load was disconnected because you hit that low battery disconnect, you will see that the clipper light will blink, just to let you know that something occurred, that your battery hit that low battery disconnect, and so it turned off the load until such a time that it reached whatever you programmed for it to come back on again. That load could come back online and start operating again.
Yeah, that was the one I was referring to, right? Because that's not called out specifically in the manual that I recall. The other one that's a point of confusion too is the OVR, the yellow light. A lot of people think that that's over voltage or over current, but it actually does 3 different things: over voltage, over current, over temperature. It lets you know that something's going on in there. Over temp is really easy to figure out because you can go into the temps menu and actually look at the FET temperature and so forth. And we were discussing this morning, and as Raechel was mentioning, that the FETs are over temperature at 59 degrees centigrade, and they stop completely and shut the unit down at 70 degrees centigrade. So ventilation's somewhat important on this. It doesn't have any fans. It's just a passive cooling system. So, if you close it up really tight in a box on a hot summer day, it risks overheating. What kind of enclosure are you usually installing these in? Is it a room? Is it a very small box? What do you have?
So usually a small box, either a Hoffman enclosure or a metal tool tough box.
Okay. Any means of ventilation there? Any vents of any type?
We usually put in some 3-inch passive vents.
Okay. All right. So there's at least some flow through there. That's good.
Yep.
All right.
Something to note is that you're probably going to see that OVR light coming on, especially on those systems that you have the 3 panels in series, where it's a... Did you have it? No, you said your system's a 24 volt system, not a 12 volt. Or is it a 12 volt?
No, 24.
Okay.
24.
Okay, I'm sorry. Never mind. You may see that OVR light though come on if you have a bigger array. Just because when you do have more coming in and the KID is current limiting at 30 amps, that OVR light does come on and people think that something's wrong, and that's not quite the case. It's just that the KID's maxed out. It's putting out just as much electricity as it can possibly make, and so that light does come on, just so that you guys are aware that it's not necessarily a bad thing. It just tells you that the KID's doing its job.
Yeah, that's right. Yeah, it will clip and limit itself.
Is that when it gets too much voltage from the solar panels?
Well, no, usually it's current. I mean, this is a 30 amp charge controller and 30 amp on the output side. So, I mean, if you've got the potential of generating 31, 32, 33 amps under perfect conditions into the batteries, it's not going to allow any more than 30. And while it's doing that full 30, it's going to be showing you the OVR light occasionally because it's letting you know that it's clipping, that there's more current there than it can process, and it's not allowing it through.
Okay.
Yeah, it'll also be, you know, if you do happen to go over voltage, it's going to let you know. I mean, we have Hyper VOC, which means you're protected it's a little bit different from the Classic. I don't know if anybody here is familiar with the Classic, where you get the Classic rating plus the battery voltage, and in this case, it is the rating of the KID, which is 150 volts plus 12. So if you're in between 150 and 162, you're not going to hurt the controller, but it does go into Hyper VOC, which means it does go into resting, and therefore it's not processing any power. So it's counterproductive to design a system where it might just bump up a little bit over 150, although an awful lot of our customers do seem to want to try that. So, all right.
Now, is there ever a reason for you to not get any of the charge lights come on?
Well, certainly, if you've got an array issue, I mean, and you're not getting anything through, that would be one condition. You should get something through even on a very cloudy day. I mean, you're going to get an extremely cloudy day. You'll probably get open circuit voltage, but if there's not enough current to get above a certain threshold, you're not going to process anything. I mean, you're not going to see, to the best of my knowledge, you're not going to see anything on the status light screen. You'll see PV input voltage on the display, but you won't see anything on the green. I mean, sorry, you won't see anything on the LED display. Yeah, that's going to be pretty heavy overcast. If you've got, this is fairly large arrays you've got on here. If you've got, say, 4 of the 285s on here, you're going to get a little something through. I would like to think that you're probably optimized for low light conditions. You might not hit your 72 plus amp hour a day target, but you would get something through. So it would be a pretty nasty day where you didn't see any of the charging lights come on.
Okay.
Has that happened to you? Is that why you were asking?
Well, we had a site. It was a system that was built by somebody else, and it ended up having to be rewired in the field. And I was, through talking with the biologist who runs the site, he was describing that they've never seen the recently received full charge light, and the 1 week and the 2 week lights have never come on.
Okay. Well, one thing that I can say is, you said it had to be rewired. If on a 24 volt system, if you put all those panels in parallel, then you're not going to get anything through, because an MPPT charge controller such as the KID needs about 33% more voltage coming in than your highest battery voltage. So I'm going to imagine that those full river AGMs probably have an absorbed voltage of around 28.8. And on the 285s, you'd be hard pressed to be, I think, let's see, you're probably looking at those 285s. I think you've got a MPP voltage of around 33 times 33%. So I mean, you're looking at you need about 44 volts or higher coming in. So if someone made the mistake and wired for parallel, that would be really bad. You're not going to get much of anything through.
Okay.
And so that might be part of the problem. The other one too is if your loads exceed your input. I mean, if you're staying ahead of your charging capabilities, a really long string of really bad weather and it just never gets up there. So why the 1 week and 2 week lights wouldn't come on would be puzzling, unless it never got up all the way to a full charge. in which
Okay.
case we're back to scenario number one where maybe the bad wiring would have an issue here, would be an issue.
Okay.
Yeah. A lot of variables. I'm just trying to think of the more common ones.
The other thing to do is to go in and check in your LED modes and make sure that in your LED modes you're set to BCM and you're not set to like RIC mode. RIC mode will make those your battery capacity meter settings go away. You have to be set to BCM mode in order for the battery capacity meter, that green receive full charge, the yellow 1 week, and the orange 2 week lights to actually light and function. So you want to make sure that you're also set correctly in the LED section.
Excellent point.
Okay.
Yeah, RIC mode was developed for the Classic originally and has been transferred over to the KID. A guy named Rick complained that there were too many flashing lights and he didn't like them, so RIC mode was born. So it's just the kind of stuff we do here. So,
Yeah.
any other questions on this particular presentation slide?
What does BCM stand for?
Battery capacity meter. We'll cover that a little bit more when we get over into the Whiz-Bang Junior.
It's basically just sort of like a visual cue for the people, who aren't as familiar looking at their batteries and knowing it sort of gives them an idea of where they're at in the charging until they're able to learn voltages and really get to know their system a little bit better.
And here's a good description of what it does here at a glance. And yeah, so if that's, good point. If that's not selected, if that feature is not turned on, then you're not going to have all those lights. So that might be as simple as that at that site you were talking about.
Okay.
Yep, yeah, under LED mode in the main menu. I think here's the part that confuses everybody the most, especially if you've used both our Classic and KID controllers, because you hit Enter on the Classic to save, but you hit Save to save on the KID. But if you've only ever used the KID, no worries. Have you done much programming on the KID? Is it just the one site you've used the KID at this point?
I think we have a couple other sites, but they're all set up with another company. And with the fiasco that we run into with the last one, we just kind of decided to bring that in-house, and so
okay.
So here we are.
Yep, no problem. Yeah, there's quite a menu structure in there, but there's a nice menu tree in the manual, and I don't know if well, I would imagine you probably have the printed out version, but 1797 is the most current, I believe, Rev E. That's the one that's on the website, and it's a work in progress like any manual. So you're going to find a couple of little glitches here and there, but for the most part, it's a pretty good manual, pretty straightforward. So. We can skip over that. It's a two-line display. So here's where we'll show you the marketing part of the presentation, and then we'll fill in a little bit with our own little tips and tricks here for this one. You're supposed to be able to parallel two KIDs together to increase capacity. So if you want a 60 amp charge controller, you can put two together and they'll function as a single 60 amp charge controller. Up to this point, this has been somewhat problematic. We have a few more bugs to work out on this. I believe we're going to be able to cure it, no problem. We're doing some testing at the moment. So if you need this feature, just be forewarned that it's still a little ways into the future, but it will be online pretty soon. And do you see any need at this point for adding a second KID paralleled?
No.
I don't think so.
Okay, all right, good. Now this doesn't mean that you put two separate arrays on two KIDs to the same battery bank. That's completely different. This is one. These are two KIDs sharing one common array, paralleling the array. Connecting it into two parallel KIDs that we're talking about here. So, one array, two KIDs. Now the other one is sync mode too, where you can actually get multiple charge controllers to talk with each other and change charging states at the same time, which is nice. They won't conflict. But again, if you're not going to be using multiple controllers, then that's really not an issue there. So here's a general rule of thumb. You're on a 24-volt battery. You know, you can go up to about 1,000 watts or just under 1,000 watts on the PV array. So it's quite possible on those systems where you've got the two SW285s on there that you'll probably see that OVR light, the clipping light. You might, you know, on a nice cold, clear day with over 1,000 watts per square meter light intensity, you probably will see that clip because you're processing the max at 30 amps. Have you ever looked at our KID string sizing tool that's on the web?
I haven't.
No, I haven't.
Well, that's one thing I would encourage you to do is to make use of this as you're designing these systems. Of course, you know, if you're doing a cookie cutter system and it's the same thing time after time, well, I suppose this is redundant. But when you're just starting out, I would encourage you to use this. When you enter in the module and array data on the left-hand side and then click Submit Parameters, it's going to put out a report that actually tells you if you're going to exceed the maximum open circuit voltage at the site, and if you've got too much PV on the KID, or if your voltage is too low coming in. Very handy little tool, and it's a nice little double check for design review.
One thing to note when you're using this string sizing tool is that it bases its calculations on, you know, full value. It doesn't look at it from the standpoint that, like, we know that a solar panel that's rated for 100 watts, you're only going to see 75 to 80% of that. It doesn't look at it from that perspective. If you tell it you're using a 100-watt solar panel, it is going to expect 100 watts out of that 100-watt solar panel. So there is, when it's doing its calculations, there is a little bit of natural wiggle room, and that's just something to kind of keep in mind when you're looking at it. I love using these string sizing tools, but we do have to remember to kind of bring a little bit of the everyday common sense stuff into it, because it takes things at face value rather than, you know, considering that there are a few variables.
Right, it's very common to use an 80% derating. I mean, you're going to lose about 20% off of any array. Dust and dirt factors, line losses, orientation losses. Most sites don't see 1,000 watts per square meter. I mean, you know, you've got haze and fog and dust and et cetera, et cetera. So, you know, 80% is a good derating factor. So your 1,000 watt array is going to average to be about an 800 watt. All right, I think you guys are past this already. You've already decided on the AGMs. Good choice. Any idea what you're using for an absorb time on those full rivers?
We haven't gotten into that yet.
Okay. Yeah, it's always best to check with the battery manufacturer to see what they recommend. I usually use a default of 2 hours. That would be the minimum. And but the battery manufacturer should be your go-to for any charging voltages and absorb time. Yeah, we talked about this here. You just don't ever want to get up over 150 volts if you can help it. And if you're doing series parallel on the 4 panels, or you're doing series on the 3, you're perfectly fine. Pretty much general rule of thumb on most of the modules that have, you know, under a 40 volt open circuit voltage, you should be fine with no more than a string of 3 on the KID. And again, you know, use the string sizer to double check yourself. Now, Raechel, here's one of the obscure things I'm not really sure of, because I have all these beta test kits laying around here, so I haven't seen a brand new one in a box for a while. Does the does the Marine version come with that mounting backplate?
Yes, the Marine version does come with the, it's the thing on the left. it'll come with that sort of like a stand, and you can either mount that stand like on a wall so that it hangs from it. You could do it in a stand fashion like how they've got it so that you can like mount it to a dashboard, or you could, like at my house, I actually have mine mounted to the ceiling and it's hanging down from the ceiling. So you have multiple options as far as that particular fixture is concerned. And then we do have a full set of directions as far as the wall mount unit, how that works. And in the RVs, that wall mount unit looks really slick. And then you can just stick it up onto the wall without the mounting unit if that's how things work best for you guys. It just sort of all depends upon what you're doing and what your application is.
So you're saying you get both with the, in other words, that mounting bracket you see on the left as well as the wall mount bracket in the center, both come with it?
No, it's an either or. You get the wall mount bracket if you get the standard kit. If you get the marine version, you get that mounting bracket that's on the left.
I see, I see. Yeah, I'm more familiar with the one in the center. That's a nice little feature where you can flush mount it on the wall, and there's a little wiring compartment underneath. It's still way too small. It's really hateful. You need little tiny fingers to get in there, and you'll blister the walls with some good language as you're trying to hook it all up. But any idea how you're going to be mounting it? Which mounting method would work for you guys? The one on the left, or the flush mount that goes straight flat on the wall there in the center?
The systems that we're putting together now, we do with that marine mount. It came with it. We're putting these in a large, rigid tool enclosure this go around, so it works out really well.
Okay, so that's working good for you. So, and that's a lot easier to wire, especially where everything's done from the back, as opposed to that flush mount. We're trying to get Robin, the owner of the company, to design a much larger one, and supposedly it's in the works, but I think I'm going to have to poke him again and get him moving on it. But all right, so good. You've got a good mounting method.
Yep.
Firmware upgrades. You probably haven't crossed the that threshold yet. I'm going to let Raechel handle this because we've had some issues with recent changes from Microsoft, like Windows 8.1 and Windows 10. But technically, you're supposed to be able to just drag and drop on this, and I know for a fact on Windows XP and Windows 7 it works beautifully. Raechel, you want to fill in just a little bit on the other issues we've been having?
Yep. If you're going to be updating in Windows 8, you're fine to do the drag and drop. Windows 8.1, we do have an updater that you will need to run to update your system first. What you will need to do is you will need to turn off any antivirus software. You'll have to download the updater, let it run, and then restart your computer. And when you restart your computer, it will restart with your antivirus software up, and then you should be fine from there. I believe you can update on Windows 10. I am still working on, we seem to have hit a bit of an issue with someone, and so I'm working with that person to see if it really is an issue that we need to address or if it's something that is just particular to this person's computer. Still working on that, so I can't really say too much regarding that. But as far as the drag and drop, I love updating the kit. It's very, very easy. You plug it into a USB port on your computer. You go into the tech menu. You tell the kid you want to update. It appears on your desktop, just like any USB stick that you might put in. You drag the firmware onto the kid. You let it go, and immediately you're done, and it just updates. We have a video detailing how to do that on midnitesolar.com/kid, and it really is just that simple to update the kid. The only thing to note is that when you go to update, if for some reason your update should fail, the kid will be non-operational until you are able to update its firmware. As a part of how the updating was configured, when it goes to update, it also causes it to basically erase whatever firmware it was running on prior. And so if somebody tries to say update with a Mac and it doesn't work with a Mac, they end up with a KID that's pretty well useless until they can get themselves a computer that has Windows or Linux on it. So it's just keep in mind that when you're updating, you need to make sure that you have a system that we work with, which is either Windows or Linux.
Yep, good tips there. Okay. Now the Whiz-Bang Junior it actually turns the KID into a fairly sophisticated battery monitoring system. And do you folks have need of this? Are you using one already, or do you have maybe another one of a different type already in the system?
No, we are not. We don't have anything for monitoring.
Okay. Yeah, this might be something you want to look into. The Whiz-Bang Junior does not come standard with the KID, to the best of my knowledge. Is that correct, Raechel?
That is correct.
Okay. You would need a shunt in line. I don't know if you have any main battery shunt in line now, but you would have to put in a 500 amp 50 millivolt standard Deltec shunt, and then that's what the Whiz-Bang Junior is mounted to in this photo. And that purple wire goes up into the auxiliary port up in the KID, and then you program it accordingly with your amp hour rating of the battery and some other parameters, and it tracks all amp hours into and out of the battery bank, and will give you the battery state of charge and the net positive or negative amp hours each day, etc. So it's a pretty handy little device, and if you're not 100% certain what your daily usage is, then this is actually a pretty handy little thing to have in line.
It's also nice in that you can see when your loads are running what you're using in real time to see if,
Absolutely.
on a nice sunny day, is the array covering what you're pulling, or is it, covering some of it and having to pull some from the battery bank. It'll give you guys a better idea when you're, when you're looking at your system and you're trying to design it, to let you know if you need to add maybe a little bit more PV, or do you need a slightly larger battery bank in order to be able to make it the full length of time that you might be gone from one of these sites.
So I threw a few wiring diagrams in here. I wasn't sure what voltage you were on, 12 or 24, and now I know. But I think I've got a 24 volt up here. Yeah, here's a 24 volt. And 4 panels in series, but this is actually pushing it. I don't even know why this is out there. There should only be 3 panels in series. Do you guys run into inspections or anything like that? Do you have to have have an electrical inspection on these systems at all?
No, not that we have been told yet.
Okay. Technically, to code, you're supposed to have a ground fault protection breaker in line there. I don't know. Do you have GFI on any of your systems?
No.
Okay.
Not the ones, and that was something we were looking at. We've ordered all of the breakers and the ground fault for the new systems.
Okay, good. Yeah, it's a good idea to have it in there. Some of these smaller systems, it may not seem to be as important, and it probably isn't overall. But if you want to be, 100% code worthy, then that ground fault protection breaker should be in there. So that's good. So taking a look at this outline here, any questions as far as for wiring or breakers or anything like that?
Now on the breakers, the positive always goes towards the source of current.
Correct.
The highest potential of current.
Correct. Yeah. So it would face toward the array on the array side. It would face toward the batteries on the battery side.
Okay.
Mm-hmm. Yeah, that's a point of confusion for an awful lot of people. My favorite ones are the people that actually follow the positive and negative literally and put the positive conductor on one side and the negative on the other and can't understand why the breaker trips when they flip the switch. You're completing a short circuit. So good you understand that.
And for the load breaker, you want it towards the. You're going to want to run that towards the controller.
Absolutely, because that's where the current is coming from.
Yeah.
Yes. hmm Yep, always toward the current source. Yeah, it took me a little while to get a handle on that myself when I first started using these types of breakers. And I understand there's some kind of a code change coming up, and the circuit breaker manufacturer is already working on a replacement. I think the code change comes online in 2017 revision, and will not allow that type of a breaker to be used anymore. So pretty soon that's going to go out the window, and you won't have to worry about that anymore.
Okay.
Yep. And what are you using for grounding?
Generally a ground rod. And I noticed that you have all your grounds going to one point there.
Well, that's in most systems. That's typical to use a single-point ground system. Otherwise, you risk introducing parallel ground paths into the system.
Uh-huh.
And in a lightning-prone area, that can be, well, let's just say rather very interesting.
Yeah.
And yeah, you get current flow where you really don't want current flow. So yeah, typically we use a single-point grounding system. Some people prefer to do it a little bit differently. In your case, do you happen to use a positive ground system, or do you ground the negative side of the system? How are you doing that?
Right now we're using the negative side.
Okay, and that's typical, and that's just fine. And yeah, I don't know if you're aware of this or not. You may be. So if I'm preaching to the choir, stop me. But you know, if you don't ground the system and you leave it as what we call a floating system, you would actually have to put breakers on both the positive and negative conductors. So, and you wouldn't be able to use the ground fault in there. All right, any questions on that? All right. And I think let's see. Yeah, this was just showing the kids in parallel twin mode here. So that's pretty much it there. I was going to let you folks sort of, come up with a list of questions, and we can answer them and go from there.
I got a question.
Sure, please do.
When you're using these sealed AGM batteries, do you actually use the equalize mode, or will those batteries kind of equalize themselves?
Well, the interesting thing is some AGM manufacturers recommend equalization and others do not. I'm not entirely sure on the full river, but some AGMs can be equalized, and that's fine. As far as for equalizing themselves, I don't know of too many batteries that are good at playing with other batteries for any length of time. So I would keep an eye on that. Typically, what I do in most of my systems is minimize the parallel strings, and in your case, you're at 2, and that should be just fine. But I do a voltage check. Obviously, you can't do a specific gravity test on these, but you can do a voltage check at rest. So if there's ever a time when the batteries are reasonably at rest, minimal loads out, no charging in, do a battery-to-battery voltage check. Even though they're wired together, you will still get separate readings. And if you're seeing anything more than about maybe 1 or 2 tenths of a volt difference, I'd be a little bit concerned about that. And if Full River says it's okay to equalize their batteries, I would do that occasionally. I would not set it up for automatic equalization. Although does the KID do auto EQ?
The KID does not do auto EQ. You have to. It's manual.
Yeah, it's manual only, and that's fine. I am not a fan of auto EQ at all. I like to be around my batteries when I'm equalizing.
Okay.
Yeah. Yeah, if you probably already know this, but if you do, they will gas. You can get an AGM battery to gas. Unfortunately, once it's gassed, it's not a battery anymore. Yeah, so it's a bad thing. You want to avoid it. But yeah, I've seen them be able to take the voltages up to 15 volts per battery, so you could get that up to 30 volts on the string. But again, I can't speak for Full River. You happen to know offhand if they recommend equalization or not?
No, I did not look at that.
Okay, all right. Yeah, I'd check into that if I were you, because it wouldn't be a bad idea to do that now and then if they recommend it. And as far as for battery sizing goes, let's see, you've got the 520 amp hours. Do you size with a certain amount of depth of discharge in mind?
Like, talking to Justin here, 50% is about where the standard is, right?
Yep. Yep, that's good. All right, so you actually have 260 amp hours usable, and so it actually looks to me like if you're at 72 amp hours or so, I mean, you're looking at a little bit more than 3 days of autonomy, and it sounds really good, actually.
Yeah. It was only a small cost to go from the 210 to the 60, so.
Yeah,
Like we originally spec'd out at 210s, but we get a pretty good deal on batteries, and so
that's
an
helpful.
extra $75 a battery. So
Yeah, that's really good. Yeah, it used to be the solar panels were more expensive than the batteries, and it is definitely flip-flopped around the other way.
yeah.
So, yep. All right. Any questions about sizing or anything?
Not on sizing, but have you guys ever tried to hybridize this with like with a wind or a? We're going to try to use it with a thermoelectric generator and kind of link these two together, and hopefully they work.
Now, link them together. Link them together. How are you saying sharing the same battery bank?
Yeah.
Oh yeah, that's fine. A lot of hybrid systems out there. Yes, absolutely. Yeah,
Okay.
what you'll wind up getting into is I would assume that the other charging source would have its own means of regulation, its own controller. And you may have a little bit of conflict between the two. In other words, toward the tail end of the absorption charge, you'll probably find that one backs off before the other, and one says, oh, I'm going to let that other guy finish it. I'm just going to loaf here for a while. And that's common. It's some people, it drives them crazy. Personally, I don't really care as long as the batteries get full. But you may have to offset charging voltages slightly between the two. And one tip I will give you, you can leave the charging voltages the same on both controllers. Vary the absorption time. Whichever one you want to hang in there the longest, make it to be the longest absorption time. So say, controller number 1 is the secondary, set that to maybe a 1 hour or 2 hour absorption, and your primary set it to a 3 hour absorb, and then it's going to hang in there longer. So little tweaking, and you can easily have hybrid systems, not a problem.
Okay. Excellent.
Yeah, especially on the 520 amp hour battery bank, it's big enough to where, if you don't get much past like a C10 charging rate, that's around 50 amps or so, then you're probably fine, and you've got the potential of 30 off the KID. I don't know what's the thermoelectric capable of doing. Do you know?
I want to say it's only like 10.
Oh yeah, so you're well within that C. You're not going to exceed the C10 rate. No, that should be fine.
Yeah, I mean it's the most inefficient thing in the world, but when you're in a deep dark canyon in the middle of December, you got to rely upon them, unfortunately.
Yeah, at that point, who cares about efficiency, right?
Yeah.
Yeah. So, no, it sounds like you guys are on the right track. This is really good. I don't have anything to add here, and unless you have some more questions.
As for like a load cabling, what do you guys recommend? Why we were using like a direct burial 12 gauge solid copper, and it seemed to work okay. What do you guys recommend?
Well, you're using solid copper. That sounds almost like it's just a standard UF cable.
Yes.
The underground feed.
Yeah.
Yeah, I mean, I'd say that's okay, but I do know that most of the terminals, do you make a transition or do you run that right up into the controller?
Usually goes into, we have like the bin rail components, the terminal blocks.
Okay.
So it ties into the terminal blocks, and from there there's usually like a pigtail that goes from the terminal blocks into the MidNite solar.
Okay, and you use a different type of cable up in there, like a stranded flexible?
Yes. Yes.
Okay, all right, that's okay. Well, then I don't see a problem with that solid. I mean, the UF is fine. I just thought it might be an issue if you were to run it all the way up into the KID because, well, first of all, it'd be hateful to maneuver it around inside there. And second of all, the terminals are rated for stranded, so.
Yeah.
Yep. Yeah, sounds fine to me. You guys, you do your voltage drop calculations for wire runs? I mean, what's your typical length of wire run between the array and the controller?
It varies. It varies anywhere from 200 to 1,000 feet. Usually if we're going like 1,000 feet, we're maybe using 10 gauge instead of 12.
Wow, that's a heck of a wire run.
Yeah.
All right, I'm going to back this off and open up something here. Can you see this on your screen?
Yes.
Okay, so let's just say you're coming in a series parallel. So let's say you're coming in at, if you're coming in at, if you're using 3 panels in series, let's say you're at 51 volts. So that's about MPP voltage times 3 in series. And you're looking at probably coming in at about, let's say what, maybe
925.
how many amps would that be? My math chip just headed out the window on me. So that would be about 12 to 14, maybe 15 amps. But you're looking at how many feet?
Let's just say 1,000.
Yeah, probably not a lot coming out the other end there. And what size wire?
1,000, we're probably going to be using 10 gauge.
Yeah, you have a 73% voltage drop. Now this is on the PV circuit, or am I misunderstanding? Is this on the load side or the PV side?
This is going to be on the load side.
Oh, on the load side, different. Okay. Now your load is what, 24 volts or 28?
24. It takes 24. It converts the 24 to 28.
Okay, so 24. And how many amps was that? What did you say, 3 before on the load side?
3 consistently, and maybe as peak of 10.
Yeah. So you're still looking at about a 30% voltage drop. But then you're saying this is pre DC to DC converter, right?
Yes.
Okay. All right. So the DC to DC converter is bumping it back up. All right. Yeah, I guess that works. That's a heck of a wire run for low voltage DC. But yeah. Yeah, if this was on the PV side, that would be catastrophic right there.
Yeah. We actually use a PV cable for our solar panels, UV rated.
Sure, sure. And it's probably fairly short wire runs then.
Yes.
Yeah.
Yeah, okay. So that's not even worth calculating. Yep. All right. Yeah, I'm not trying to second guess you here. I'm just trying to help you out.
No, that's fine.
You know, these little calculators are really handy.
All of it's a big help.
Yeah.
All right.
It's a learning curve as we're going here. As we kind of farmed that out, and so any help that we're getting, we appreciate.
Yeah, not a problem. Of course, ongoing, we're here for you as you come up with more questions. And you start turning screws and running wire. I'm sure you're going to have some more. So, all right.
I guess you're the only one that's really set up the KID on our system. I'm trying to think of any other things. Got it.
Yeah, I think one of the most helpful things that you can probably access here. Let me see if I can find it quickly. There it is there. I guess you'll have to look at it sideways here, but these are the 2 pages of menu tree, and I tell you that this has helped me a lot to learn it when the KID first came out, because that menu is rather extensive, and it doesn't mean you're going to use every last little bit of it, because you're not using the load end of it, you're not using AGS, but at least you're going to be able to maneuver through the menu. I think this is something you may want to even print out and keep separate.
Yeah, most definitely.
And this is in the manual?
Yes, it's in the manual. It's also available on our website, and this is version 1797 Rev E.
I do recommend that people print that out and just have it handy. I mean, That's what I had for a while. I'm now to the point where I pretty much have the menus memorized, but that's because I have to go through them on a very regular basis. But yeah, it's a really handy thing to have around just so that you can quickly find what you're looking for.
Okay.
Yeah, and that low voltage disconnect is kind of hidden. What's the little trick there, Rachel? It's only settable from one spot, and then it carries throughout all of the other settings.
I am trying to remember how that works. Jim has it down to a science.
Yeah, I know he does. Yeah, you'll have to forgive me because I was hired to support some of the more higher end components here, and they said, "Oh no, don't bother with the KID," and yet I wind up supporting the KID a lot. So bear with me on my learning curve. Um, the Yeah, I believe. Yes, right at the very top. I don't know if you can see my little thing on the screen. I don't know what shows up on this presentation, but right here at the top under the load menu is low battery, disconnect, and reconnect. I believe you set it here, and then it automatically transfers all the way down to all these other settings, so you don't have to set that each one. I don't know, do you know if you've ever had any of your systems shut down in low battery disconnect? Your batteries ever get that low?
We have the one that we were having issues with that we're helping them out with. We believe that it did shut down.
Okay.
We were working with them, and we had the system running, and then we were able to monitor it through a modem.
Mm-hmm.
And at one point it went down, so we're not sure if it was because of power. But that's what we're guessing, is that the batteries just drained.
Sure. Yeah, that's that low voltage disconnect is critical in an off-grid system because I don't know if you're familiar with the term bootstrap charge, but if this gets below, I think it's 9 volts, 9.5 volts, if the battery gets that low, the KID will shut off. And you can come back to a nice sunny day with lots of solar capacity, and you can't charge your batteries because the KID just doesn't wake up. And then you wind up having to charge your batteries so you can wake up the KID so you can charge your batteries. It's I've had to do it on whole house systems, and it's a discouraging thing. So if you set that LVD is not too awfully low, you have a buffer there so that when you do show up on site, you have enough voltage there to work with, and the KID will still be awake.
And where is that in the menu?
That's at the very beginning of the load menu.
Okay.
All right, on off. Not on off. Right here, low battery, disconnect and reconnect. So you tell it when to turn off the. Now, actually, that LVD, that's actually using the load circuit. Now that I think about it, so you're not using the load circuit. So this discussion just went out the window. My mistake. Yeah. So. Yeah, that's just going to sit there, and you could set that, but it's not going to turn anything on and off. So.
Would it be an option for them to use the load circuit with that DC to DC converter, or no?
Well, it's quite possible. I mean, you're sending. What do you pull? What's your current rating? What kind of current are you sending down the line on that 1,000-foot run? I mean, you're anticipating sending 5 amps, 10 amps, 20 amps, or that 3 amp full time that we talked about?
We're hoping that the load will draw a consistent 3 amps, but maybe it's peak of what, 6, 7 amps?
That's not 6.
6 amps.
Right, but you've got 30 to work with off of the load circuit off the KID, so that's a definite option. You know, if you were to use the load circuit to feed that load at the other end, then this is a valid discussion for a low battery disconnect.
It would save your batteries in the long run.
Mm-hmm. Definitely, because I'll tell you, AGMs, if you pull them down, 8, 9, 10 volts, and they sit there for more than a day or two like that, they're not in very good shape anymore.
Okay.
Yeah, you might want to play around with that. You might want to see if that'll work for you using the load circuit to power that load, and then you do have that LVD function to fall back on. The other thing I wanted to mention too, Raechel and I were discussing that one of the biggest things, and I don't think we stress it enough in the manual, and that's to calibrate the KID when you first get it. So that if you've got a decent meter, like a Fluke or something like that, you can measure your battery voltage, and then you calibrate the KID on both the battery and PV input side to match the actual readings, because it can come from the factory off just a little bit, and it is definitely very important to calibrate that. That's covered in page 37 of the manual, by the way. The other thing is not to have common negatives. Are you aware of that feature on the?
So don't have the negative of like the solar array in line with the load. Keep them separate.
Right, or in line with the battery negative either. Other controllers, you can just have a common negative bus bar and all the negatives go there, and you can't do that with the KID. It has sensing circuitry on the negative side, and it messes it up pretty significantly, because I had common negatives in mine when I first hooked it up, and it was very strange until I separated those negatives. So you'd know right away you've got something wrong.
Another common thing that we see with people who have common negatives is they have the load circuit negative on the same bus bar as their battery negative. So then they try and set up something on the load circuit, and like the load circuit comes on, but then it won't go off for them. And it's because they've got both the negatives on that same bus bar. And so even though it's told it to go off on the load negative part of it, it still has access to run from the battery negative because they're both sharing that same bus bar. So,
Right, because the controller makes or breaks that circuit on the negative side. So, yep. And the only other caution would be on the load circuit, not to put a heavy surge load on there or an inverter. I think that DC to DC converter it would be just fine, but not a heavy surge load. It does nasty things to the KID.
Yeah. What's your definition of surge load?
Like a heavy-duty pump, or even an inverter. Because when you first turn an inverter on, it charges the big capacitors in the inverter, and it tries to pull a lot more than 30 amps through the load circuit, and it does it so quickly that it defeats the protection circuitry in the KID, and it'll let the smoke out of the KID for sure.
Okay, so like 30 amps is what you're concerned with. So if like our copians, if they maybe push 9 to 10 amps initially, that's fine.
Yeah, that should be just fine. Yeah, it's something. Heavy duty surge is something that's going to try to pull 50 or 100 amps for a split second. Something that has a lot of capacitance in it, like an inverter.
sometimes we've had kids who do the electric cars, and they've had some pretty interesting motors hooked up to the KID that they put on the load circuit. And it's that sort of a surge, too, that we've seen, and they haven't been terribly successful operating off of our load circuit. It's that sort of, really big draw.
Okay.
Right. Yeah, the best one is the one that hooked his load circuit up to his AC main panel in the house, expecting it to produce 120 volts. We still haven't figured that one out yet.
I think I missed that one.
Yeah, that was unusual. It was we see it all. We get some really interesting. I think we need to write a book someday. I've been saving a lot of these in a file. Well, gentlemen, I think that runs through my list here. I can't think of anything else. Any final questions?
The people that were installing the systems for us, on the DIN rail mount, they were using these breakaway fuses that you can just pop up, and you can turn off the system to the load or to the battery. A lot of times when we disconnect, reconnect the loads, sometimes the MidNite solar would shut off and kind of stay off for a while. Is that typical?
I'm not sure I fully understand what you mean. What circuit are you disconnecting?
Just conduct a blank screen.
Yeah.
Yeah, we would just do like a blank screen on the MidNite solar. Basically, the positive side for the load will have a fuse. You can just flip it like a switch, and the fuse, disconnects. So you disconnect the load. The same goes for the battery banks. They would also have one. And I believe even the solar panels have one too, right? And sometimes, like when we're just testing the operation, like we want to disconnect the load and just let the batteries and the solar arrays do its thing, so we can see it charge, see the solar panels in action. And then we would add the load. But if you do it in sometimes if you do it in the right certain combination, like you disconnect the load or disconnect the batteries, something happens where the MidNite solar just kind of goes blank. But usually we have to give it time, like a few minutes before we can reset all the fuses and it comes back online.
Interesting. So it sounds like something scrambling the microprocessor or something. Huh.
Now,
Yeah.
should the going from the fuses to the breakers, would that make a difference in that situation?
It should. You're saying you've got breaker and fuse in line on the same circuit?
No, the company that had supplied some of these used just fuses, no breakers.
Okay.
And what would happen is when they use the pop the fuses as a switch.
Oh, are these the touch safe fuses, the ones that rock out and then you can reach in and pull the cartridge fuse out?
Yes.
Aha, those are not load rated. In other words, you're not supposed to disconnect those under a load. I'd be willing to bet you had an arc in there, and that noise generated from the arc probably scrambled the microprocessor in the KID.
Okay. And you just had to wait for all the internal capacitors to discharge before it reset.
Right. The best thing you can do in something like that is shut down all incoming and outgoing. Shut off battery and PV to the KID and wait about 30 seconds, maybe a minute, and then fire it back up again.
That's exactly what we had to do.
Yeah. In other words, that was
what we saw.
That was the magic ON OFF switch. You rebooted it just like a computer. Yep. Yep. So you did the right thing. But I'd be willing to bet it was because of those touch-safe fuses. They're not supposed to be disconnected under a load. In fact, if you have a heavy enough load, they'll just about explode in your hand and melt down. We've got some pretty cool photos of that. The circuit breakers are load break rated, so you can turn those on and off without any issue.
Good. That's why we're going.
That's why we're going that route.
Excellent. Yeah, much easier. And much easier to reset, too, if anything happens, as opposed to replacing fuses. So.
Yeah, when I talk to people, I do try and encourage them not to use fuses and to use breakers because of that reason. It creates a really easy on-off switch, and also we need to be able to turn things on and off when we're troubleshooting.
Yes.
Yeah, I can't tell you how many times someone has, huge systems, 10, 15, 20 kilowatt PV systems with the multiple charge controllers and 16 to 20 kilowatts of inverter, and there's not a fuse, breaker, or disconnect anywhere in the system. Well, I'll have to pull a battery cable off to shut it down. I'm horrified. I said, no, don't touch anything. I don't want to blow you up. So. All right. Any other questions?
I think that's it.
All right, guys. Well, hopefully this was helpful, and just know that as you think of more questions, we are available, and questions are us. And if we don't have an answer, we'll make one up for you. It'll be fine.
All right.
Both of our email addresses are on the website, so please feel free to drop us emails or call and ask for us by name. Usually, if we're not both here, one of us is usually around. So, and Jim is also
That's
a
right.
fabulous resource too.
Yeah, if you as you move along in your learning curve and you want to really get down into the weeds, you want to start talking about the microprocessors and any other little things like that. Jim is your guy. He loves to tear things apart and experiment, and he's really into the obscure stuff. So between the three of us, we'll answer your questions.
Very nice.
Okay, well, thanks for the presentation, and it was very helpful.
Well, good. Glad you liked that. And,
We'll make sure to send, we're putting our first system together this week, so we'll send you some photos of what we have going on. And
yeah, that would be great.
Fabulous.
Yeah. Fish photos too. Yeah. So,
will do.
all right, guys. Well, this has been good, and thanks for using MidNite Solar products.
You betcha.
Okay, thank
Thanks,
you.
Roy. Thanks, Raechel.
Thank you.
Thank you.
All right. Take care, guys.